Now we look at y equal to minus 1 over x. So our k is equal to -1, which is less than 0. Again, we cannot divide by 0, and therefore 0 cannot be in the domain. So for hyperbola, whether the k is positive or negative, it's all the values except the number 0. And it's for the same reason that we discussed for 1 over x, the range will also be all the real numbers except 0. And for the same reason that we had the vertical asymptote of 1 over x as x equal to 0, we will have the vertical asymptote for minus 1 over x, also x equal to 0. And the same for the horizontal asymptotes. Since we know that x and y are inversely proportional, but we have a k value is equal to -1, there it is. So it implies that if I have a positive x, then I will have a negative y, because my answer should be negative. So if I start with a plus, then I must put a minus there to get a negative answer. And if x is negative, then y is positive, because I will then have a minus times a plus, which also gives me a negative sign. The lines of symmetry are exactly the same. Y equal to x and y equal to minus x. The green broken lines on the graph, I will show it just now. So in this case we have our lines of symmetry exactly the same as for 1 over x. We have the line y equal to x and the line y equal to minus x. When I substitute x into y equal to minus 1 over x, I get a value of minus 1 over x. But if I substitute 1 over x, I'll get minus x. So the product of x times minus 1 over x is equal to minus 1, which is our k value, and the product of 1 over x times minus x is minus 1, which is our k value. If I put negative x into minus 1 over x, I will get 1 over x, and the product of these two is 1, and the product of these two is 1. So if I have minus x, 1 over x, then minus 1 over x, and x is also on our hyperbola. In this case, we will have the vertices minus 1 plus 1 and plus 1 minus 1, and we will show how we got to that in a while. And for negative, I will always have my hyperbola in the second and the fourth quadrant. If I draw the graphs, then we will have second quadrant, fourth quadrant, and this is my lines of symmetry. It means lines of symmetry means if you fold it on that line, you will get exactly that mirror images about the line y equal to x and mirror image about the line y equal to minus x. So this is my function. Now our vertices here, our vertices are c minus 1, 1 and d 1 minus 1. And we can solve y equal to minus x and y equal to minus 1 over x simultaneously. Then we get minus x equal to minus 1 over x. Again, we will have x squared equal to 1, so x is equal to plus or minus 1. And because of the negative sign there, then we will have, if x is equal to plus 1, then y is equal to minus 1. If x is equal to minus 1, then y is equal to plus 1. So there we swap the signs. So this is the vertices. And you now have to memorize these two functions, and again I will call this one where my k is positive, I will call this my mother function, and everything from there onward I will refer to either this one or to this one. This is my reflected mother graph. Okay, so you have to know this by heart. We can also say that y equal to minus 1 over x is 1 over x reflected in the y-axis, and is also reflected in the x-axis. So just mirror images. The one is just a mirror image of the other one.